Hello. The next video is going to be about maps. Now, maps are very closely associated with sets. In fact, there's one set of slides called Sets and Maps that you should review. So what is a map? A map is an association between a key and a value. So a map is a function from one set to another set. So every key has a unique value. The key itself is a set. And once again, there are two classes that implement the map interface. There's a map interface, and just like with sets, there's hash map and tree map. So here's an example of a map. The keys on the left and the values on the right. The keys are strings or names of people, whatever, and the values are colors on the right. So just like sets, a map has an interface, and the keys themselves are a set because they map to at most one value. And here are the three main methods that can be used to retrieve the keys, the values, and the key value pairing. So if you go down to the middle to key set, that returns a set of the keys, in our case the strings. Then down at the very bottom is a collection that returns the values that map from the keys, all the values. In our example, the three colors. And then up at the top is the key value mapping. It's a set of all the mappings. So how do you use it? Well, very simple, very similar to a hash set and tree set. You declare a hash set or a string set, a hash map or a tree map, and then you can put strings and values. You can change them, and you can get the value associated with a key. All you have to enter is the key. You don't have to know the value. And if you use remove, the remove method, you will enter the key, but you will remove the key and its association with the value. So you can use a for each loop, or you can use a while loop with has next, just like before. If m dot has next, and then next. So here's an example of using it, using our string and color combination key value mapping. The previous slide corresponds to the diagram earlier. And they print out the RGB values of each color. If we used a tree map, then the keys would be sorted, so Adam would come first. So what's the difference between a set and a map? The set has unique elements like the keys, but a map stores an association between keys and values. The collection of keys of a map is a set. First of all, it returns a set. Secondly, the keys have to be unique. So in order to satisfy the hash code contract, you need to have compatible hash code and equals methods. And the good thing, as I've said about strings, is that the hash code and equals are already defined. So here's an example of a class called coin, which has an equals and hash code method and a toString method down at the bottom. And here's how to use it. You instantiate the different coins, and they're not asking you in the bottom line to compute the hash code. They're asking you to compute the for each loop down at the very bottom, what gets printed, and what, let's go back to the two-string method. It prints the value and the name. So for the first one would be 25 and quarter. So that's it for the video about maps. Be sure to watch to view the supplemental slides on HashMap on maps, especially slides 4 and 5, because it will show up.